Okay, today we're going to talk about Chapter 6. We're not using the book for Chapter 6, so this is going to be replacing Chapter 6 in the book. The first section we're going to talk about is the substitution method. So, as you can see, you have a warm-up problem right here. We will be doing this one in class, so make sure that you know how to do that. This is review, something you've already done before. And then it says, on scrap paper in your book, I want you to try to solve this problem. So why don't you go ahead and pause the video, and I want you to try to solve this problem. Okay, you should have tried to solve this problem. My guess is you were not very successful trying to solve this problem unless you already know the substitution method. So we're going to go on and we will come back to this problem. So first off, what does it mean to substitute? Well, if you had done the warm-up problem, you took the numbers 3, 4, and 5, and you replaced x, y, and z with those numbers. That is what substitution means, to replace one thing with something else. In this case, you're replacing a letter with a number. But you can replace anything with anything else. So if you say you know that x equals 2 times y, you could replace that x with 2 times y. Substitution simply means replacing one thing with something else. So that's what it means in English, it's what it means in math, and we're going to use it. So like if you have a substitute teacher, you're replacing the teacher with a different teacher. That's what a substitute teacher is. So substitute just simply means to replace with something else. So this is an example of substitution. There's several different ways to solve this. We're going to use the substitution method. We like using the substitution method whenever you see something like this, y equals a number or x equals a number, because this is substitution. What this is saying is that this number y, remember y is a number, is exactly the same as this other number x minus 3. That these two things are identical. So anytime I see a y, in its place I can put in x minus 3. That's what this says. Well, we'll look at the other equation up here. 4x plus 10y equals negative 2. I don't know what x is, I don't know what y is, but I can tell you that y is the same thing as x minus 3, so we're going to substitute. So wherever this y is, we're going to replace it with x minus 3. So I'm going to do it over here. So I'm starting reading left to right. It says 4x, so I'm going to write 4x plus, next thing I see is a 10, so I'm going to write the 10. And now I got this y. Now before this is 10 times y, so I'm going to put parentheses for times. And instead of writing y is the same as x minus 3, so here's our substitution. Instead of y, we're going to write in its place x minus 3. Close the parentheses, and next I see equals negative 2, so I have an equals negative 2. So we have now substituted in x minus 3 for this value y because they are equal. That means they are exactly the same number. That doesn't mean that x and y are the same number. It's that x minus 3 is the same number as y. So there it is. We now have only x here, so we can actually solve this problem. This is something you've seen before. It might have been a while, but we can see it before. First off, we have 4x. We're fine with that. We have parentheses here. We're going to need to use the distributive property. Remember, the distributive property says anything outside gets multiplied inside. So I got the 4x plus from out front. Distributed property, 10x times x, or 10 times x is 10x. So I'm going to write 10x. We got to go back. We got 10 times a negative 3 is negative 30. So I'm going to write negative 30 equals negative 2. So I'm almost done, but I got a couple more steps to go. The next thing is I see on the left side I have x's in two different spots. I see a 4x over here. I see a 10x over here. So we're going to combine like terms, and I'm going to simply add them up. 4x plus 10x. I got 4 of these x's plus 10 more of these x's. That means that I have 14 x's. So I'm going to write 14x because that's what 4x plus 10x equals. I still have this minus 30. I haven't done anything with it. I still have my equal sign. Equal sign doesn't move. It always stays in the same place. And I still have a negative 2 on the right-hand side. Okay, so I'm looking at the left-hand side. I see a 4x. I see a minus 30. These are unlike terms, so I can't do anything else on the left-hand side. But I now have a two-step equation. So now I can solve it like we've done every other two-step equation. There's two things that have to move to get x by itself, the 14 and the negative 30. We like to start with the plus or minus, so I'm going to start with this minus 30. I'm going to add 30 to get rid of that minus 30. If I do it to one side, I must do it to both sides, so I'm going to add 30 to this other side. These cancel out. Negative 30 plus 30, I'm left with 14x on the left-hand side. The equals is still in the same place. And over here I got negative 2 plus 30, and that ends up being 28. So one more step to go. This says 14 times x. We undo times with a divide. If I do it on one side, I do it to the other side. 14 over 14 is 1, so this is 1x, or simply the number x. And on the other side, I get 28 divided by 14, which is the number 2. So x ends up being 2. That means if I go back to this original, way up here, this x is really a 2. We just didn't know it until now. But this x right here is also a 2, and any x I see in this system is going to be the number 2. It doesn't matter where. So I get to pick. I can either use this top equation, or I can use this bottom equation. I like this bottom equation because I simply have 2 minus 3 to figure out what y is. Up here I would have to solve for y. So let's use this bottom equation. This is where we take our answer, where we had x equals 2, and we're going to plug it into one of the other equations, and we like to pick the simpler one. So I'm going to plug it into this bottom equation. So I see y equals x minus 3, and instead of an x, I said minus 2 earlier, should have been minus 3. Instead of an x, we just found out that x is 2, so we're going to replace or substitute once again x for 2. So I get y equals 2 minus 3, and we're simply going to subtract. 2 minus 3 is negative 1, so y equals negative 1. So now we know what y is, we know what x is, so we have now solved the system. We have one solution. The solution is x is 2, and y is negative 1. So there's the solution to our system of linear equations. Sometimes I write it as a point. If you want to write it as a point, it would be 2 comma negative 1. That's also okay, because remember we have x and then y. If you're going to write it as a point, make sure you have x first and then y second. You cannot have this reversed. If you write them out separate, where you have x equals y equals, you could reverse them. We typically put x first, but there's no rule that says you have to. So there's our solution. We've substituted. There's lots of steps here, but all these steps are things that you can handle. Let's look at a different example. So on this example, this happens to be the one I asked you to solve earlier. We have x plus y equals 5, 5x plus 4y equals 10, and unlike the previous example, I don't have a very nice y equals or x equals somewhere, but in this top line, I can solve that for x or y really easily by simply either subtracting y or subtracting x. And honestly, it doesn't even matter which you pick. You get to choose. So last time we solved for y, so this time I'm going to solve for x. So we need to move this y by itself. So I'm going to rewrite that over here for us. X plus y equals 5. I want to get x by itself, so I have to move this y. The way I move that y is, since it's added, I'm going to simply subtract it. If I subtract it on one side, I got to subtract it to the other side. So on the left-hand side, y minus y is 0. I'm left with x. On the right-hand side, these are unlike terms, so we're simply going to write it 5 minus y. I now have something that I can substitute. This is saying that x and 5 minus y are exactly the same number, so in the other equation, the one we haven't used yet, we are going to replace every single x with 5 minus y. So I'm going to do it right here. This x is now going to be 5 minus y. So I'm going to start with this 5. It's still there. It was 5 times x, so we're going to do a times. I'm going to use the parentheses for times. Instead of x, I'm going to use 5 minus y because they mean the same thing. So I'm going to replace x with 5 minus y. Then I see a plus. I see a 4y equals and a 10. Just like before, I only have y on one side, so we now should be able to solve it. I see parentheses, so there's a distributive property. That's something that you'll see a lot. So I'm going to use the distributive property again. I got 5 times 5 is 25. I got 5 times negative y is negative 5y. Outside the parentheses, now the distribute only applies to the parentheses. This is not part of the distribute property. I got a plus 4y equals 10. Now I'm going to combine like terms. I see a negative 5y and a positive 4y. Those combine into negative y, so now I now have 25 minus y equals 10. This is another two-step equation, so we need to get y by itself. I have to move this negative. I have to move the 25. Let's get rid of this 25 first. This is a positive 25, so we're going to subtract it. And if I do it to one side, I have to do it to both sides. So I'm left with negative y equals negative 15. 10 minus 25 is negative 15. I don't want a negative y, so I either need to multiply by a negative 1 or divide by a negative 1. It doesn't matter. But what happens is the negative switch on every spot. So this negative switches, as will this one. So I end up getting y equals 15. So we now know that y is 15, and we're going to use that in our very first equation right up here. And we're going to plug it in to figure out what x is. So I got x plus y equals 5. We now know that y is 15. So this y must be 15, as is this y down here. They're all 15. So I got x plus 15 equals 5. We need to solve it for x, so I got to subtract 15 from both sides. So x ends up being a negative 10. So there's our answer. X is negative 10, y equals 15. As a point, you would have a negative 10, comma 15. X before y, because points are always x comma y. All right, if we look at the next section, I want you to try these on your own. If you've already done them in class, great. If not, go ahead and pause the video and practice right now before I solve them. Okay, I'm going to assume that you've already solved them, so now I'm going to show you how they're solved. Here we got a y. We're going to plug it in right here because y and x minus 1 are the same number. So reading the top, I see 2x plus 2, and instead of y, I'm going to use what it equals, which is x minus 1, equals 6. So I got 2x plus 2x, distributive property, minus 2 equals 6. 2x plus 2x, combining like terms, is 4x. So I got 4x minus 2 equals 6. This is a two-step equation. I got to move this 2 to the other side, so I'm going to add 2 to both sides. So I end up getting 4x equals 8. Divide both sides by 4, and x ends up being 2. I'm now going to take that 2, and I'm going to plug it into the second equation right here, because I now know this x is a 2. So I get y equals, instead of x, I'm going to write the 2 that we now know it is, minus 1. And 2 minus 1 is 1, so y ends up being 1. So your answer should have been 2 for x and 1 for y, and as point form, it would be 2 comma 1. Solving this one, we can solve it for either x or for y. I'm going to go ahead and solve it for x. So let's subtract y from both sides. I end up getting x is equal to 1 minus y. We're going to substitute that into this top equation right here. So I got 2 times, and instead of x, I'm going to use what x equals. So we're going to use 1 minus y plus 2y equals to 2. Distributive property, got 2 times 1 is 2. 2 times a negative y is a negative 2y. Then I still got this plus 2y equals and a 2. Combining like terms, I see 2y and a negative 2y. These equal 0. So they're going to cancel out. I'm left with 2 equals 2. And, uh-oh, I just have a problem. There's no more y. Well, that's okay. This sometimes happens. Anytime either your x or y vanishes, and you're just left with a statement like this, it will either be true or it will be false. If it is true, and 2 does equal 2, so this is true, this means that there is infinitely many solutions. This is our case where we have 2 lines that are the same. So anytime you see a true statement here where the x and y's have vanished, your answer should be infinitely many solutions. Okay? If by chance you get a false statement, you get something like 2 equals 1, which is clearly not true, this means that there are no solutions. That would be our case of our parallel lines. So like I told you yesterday, or the day before, last time I saw you, most of the time you'll see one solution like you did over here on the left, but not always. If you ever get to a situation like this where the variables have fallen out, you're left with a statement. True means infinitely many solutions. That's what you write. This is the answer, infinitely many solutions. If it's false, you are going to write no solution. Okay? So for this particular question, the answer was infinitely many solutions. And that would be it. Make sure that you have already posted something in discussion board post. Tell me what you've learned about substitution method, and make sure that you understand this. If you have any questions, don't be afraid to either ask them in the discussion board post or ask them in class or ask me sometime, either email or in class.